Okay, ladies and gentlemen, questions regarding 3.2, 3.3, 3.4, the homework for Wednesday or Friday's recorded lecture. Yes, ma'am. 14, 3.2. Okay. Rather than do 14, unless your question is specific to the 1 over part, would you rather look at 13? Okay. So, five t over t cubed minus t minus 1. So what's the question you've got specifically in regards to this setup? If I were looking at a limit, yes. But I'm actually just looking for the derivative, right? And I'm dividing here. I have a rule strictly based for quotients. I can just go directly to that. I don't actually need to resolve an indeterminate, which is where that conjugate expression idea is used. I'm just looking to take a derivative. If I'm just looking to take a derivative, where I have a quotient with the top and the bottom, I need the derivative of each of those. So what's the derivative of 5t? Okay. And the derivative of the denominator here, t cubed minus t minus 1. Perfect. And now I play my rhyming game. I take the derivatives one at a time. The derivative of the top times leaving the bottom alone, t prime b minus b prime t, reverse it. 3t squared minus 1, 5t over the bottom all squared. That's the entirety of what I have to do in this set. Simply take the derivative. Now, we could go through and do some simplifying here. If we were going to do something with this derivative, I would advise that. But since I'm not planning on doing anything with it at this point, I would leave it just like this and walk away. But you could multiply out all that stuff on top and gather all your like terms and see if you could simplify it. You're welcome. More questions? Yes, Jack. Ask me more things. The other version of the quotient rule that I hear frequently doesn't use T and B, but instead uses high and low. In which case you get low D high minus high D low, and everybody sounds like Cad Calloway. Scat singer from the 30s. And the bottom is low squared, so it's low, low. Take your pick. That's also why on Friday I said that we can use the chain rule to replace the quotient rule. If we don't like doing the quotient rule, you can always rewrite a quotient as if it were a product. And then there's a chain rule portion. Ugly to the -1 becomes -1, ugly to the -2, and that's why the square is on the bottom. And that's where the little nesting doll picture comes into play. Yes.
Do you want us to multiply it out?
Only if we're going to do something with it. So again, just like I leave the quotient rule like this, if I'm doing a product rule problem, say this, I could multiply it out, then do derivatives. I could multiply it out after I do the derivatives. But if all I want to know is, can you do the derivatives? Then you can stop right there. So that's the derivative of the first times the second. Leave the first alone, do the derivative of the second. If I were going to do something with my derivative, now what do I mean by do something? Well, let's say I was going to take a second derivative. If I was going to take a second derivative, leaving it like this is going to be uglier, right? So I'd multiply it all out, gather all my like terms, and do the second derivative. Or if I was going to try and set this equal to 0, where are my tangent lines horizontal? Or set this equal to 3, where's my tangent? Where do I have a slope of 3? It's harder to solve when it's written like this. But if I need to proceed algebraically, that's where I find it useful to simplify. Otherwise, I don't bother. You're welcome. Please note, this is the last week of February, and that means that next week is spring break. And upon our return, we're in the middle of March, right? You can't exactly have March Madness, but I can have something close to it. Because upon our return, unfortunately, it's a Saturday, we have March 14th, 3.14 is Pi Day. So we're going to have a little bit of fun that week. And on Wednesday, the 11th, we have a calculus B, like a spelling bee, with a calculus B. It's technically for people who finished Calc 1, but you should come and see what we've got going on. On Friday, the 13th, because Saturday is Pi Day, we're going to have poetry competition. You know what a haiku is? With certain syllable, we're going to write haikus. 3 syllables, 1 syllable, 4 syllables. There'll be a pie for pie contest. Last year's winner recited 150 digits of pi from memory. Anybody want to see the thing break that record? But the person who recites the most wins pie. There'll be a set of trivia contests throughout the day on Friday. And then the week after that, on St. Patrick's Day, is Tutor Appreciation Day. I wanted to give you all a heads up so you could pencil this in, so that you can attend and enjoy all of the fun activities we have for March Madness. I have no reason to leave you all nailed to these chairs. People, this is for you to ask me questions. If you don't have them, I'm not going to ask them of you. That's what the exams and quizzes and homeworks are for. If you don't have anything else, I don't see a reason to leave you in these chairs. I will see you on Wednesday. When the assignment is due. You too.